This is video for routine 105 of the Polygon scan game. At first, that's T to 24, W to 210, X and Y position to 212, 3, a color for light blue, and then it makes the rectangle. Immediately following that, it says box that as clickable as click number 4. Then the very next instruction says, if there was a click number 4, continue on, but if there isn't, go to FE. That's down here. Well, if they did click on that rectangle, it adds 1 to show polygon, and then mods it with 2. So show polygon is going to be a 0 or a 1. 0 meaning don't show the polygon, a 1 meaning show the polygon. So this is the toggle switch for showing the polygon. Then it adds a little to X, a little to Y, color black, font 416, so it's bold 16 points, and then it puts the text in that rectangle of show the polygon. That's what was being clicked on. Then the next line after that says if it's show polygon is not equal to 1, go to FI. Well, that's way down yonder there. Well, if it is a 1, it continues on to show the polygons. First, it fills 200 values at backwards with 0. Backwards is going to be used to tell it at which XY positions in the main polygon have a bridge. That's what backwards is for. Which positions, XY positions of the main polygon have a bridge. It marks that none of them do. Then it continues on and says the count of them, which is going to put an N, is starting at 0. Then it's going to go for I of 0, and down here there's the next I, 7, 1. It's going to go around here 8 times. That's for every one of the sub-polygons that need a bridge. So it goes to the very first one, and it says for J of 1 to next J, each count 1. The first each count is for the number of XY positions in the main polygon. So it's going to go around here for every position that's in there. And here you're going to see what it's going to do is it's going to match the X position in the main polygon with the X position in the sub-polygon, and if they match, it's going to continue through here. If they don't match, it goes to FF and goes to the next point in the main program and see if it matches to the bridge for this particular sub-polygon. Well, if they do match, then it sets the backwards value for that one to I plus 1. That's what it sets the backwards to it. It found a bridge. And then it adds 1 to N because that's the number of bridges that it found. And then it goes down here to FG. It found the one for that particular sub-polygon, so it says now go to the next sub-polygon and find a bridge for it. Well, this is the first section of this routine 105. Now I've highlighted the next section in green of routine 105. It starts out by setting the Z control register to each count. Well, at that offset in each count, it's the number of entries in the main polygon. Then here it moves that number of entries from the main polygon's values into a new list called .ax and .ay. The A stands for all of the lists. All of the entries in all of the polygons are going to be placed in this new list, but first we're putting in the list the main polygon's entries. Now it sets the value of j to the each count. Again, that's how many entries there are in the main polygon. And then it says for I equals 1, and down here we have the next I for each point in the main polygon. It's going to go around the loop here, but it's going through it backwards because j starts at the end and gets 1 subtracted from it each time. Well, if there is no bridge at backwards plus j, we go to fh and we just subtract 1 from j and go to the next lower point in the main polygon. Well, when it finds one of them is a bridge, then it sets k equal to which subpolygon it is, and then it says it's going to move the values at offset j that we already have in dot A to a holding area for hold x and hold y. It's going to insert the subpolygon's values into dot A, but in order to do so, it's got to save what came after the jth position. Now it's going to insert the subpolygon's values into the A list. Sets m equal to the number of entries there are in the subpolygon list. It sets h to the polygon's number and multiplies it by 200 because in the .p list here, they're all separated 200. That is, the main polygon is at 0, then polygon 1 is at 200, 300, 200, 400, 600, and so forth in this list of .p. So it gets the offset in h here of where this particular polygon's entries are and moves that into the position, but not the jth position, because that's where the bridge point is, but 1 past that position. So then it moves them all in there, but now we have to put the end back. So now we set h to m, and we add to h 1 plus j. That puts us at the end of the values here that we put into the A list. Now we can put the end of it back, the part that up here we put in the hold x and hold y. So we put those positions back at the end of the list for dot A. And then we say we're going to add m to the total number of values we now have in these lists, the A list. It's going to be 1 because we duplicated the bridge point, plus m new values that we put in the list. Then here we know it subtracts 1 from j, goes around the list again and says, is there a bridge point at this position? And if there is, this is repeated. Now, once that all of the entries have been put into dot A, we take the dot AX values and the dot AY values, and we make points for a master polygon to be drawn. We make the color 400, which is a dark red, and we say, make the polygon fill it in. I'm going to go to the program now. This is the whole polygon filled in. This A was created not by doing 2 polygons, the main program, and a main polygon and a subpolygon, but they're both in the same list. JavaScript can do one with the other. Now I've highlighted the last section in routine 105. Sets tall to 24, wide to 150, XY position to 455.3, color 444, which is a gray color, does a rectangle fill, and then immediately after that it says this rectangle is clickable as number 5. Well, next thing it does is it says, was number 5 clicked? If it wasn't, it goes to FK, which is down here. Well, if it was clicked, then it continues on, and it sets K equal to the active index, and then it checks to see if what's at that index is one of the start names. Well, you can't take them away. Those are not XY values. So it goes to FK again and doesn't do anything. But if it's not a start, it says, all right, I'm going to move the 200 values at 1 ahead of K to K for both X and Y. Therefore eliminating the kth position, because what was above it now gets moved down on top of it. Then it says set the X value at the end of the line to 4 nines, indicating it's the end, it's a start position. Then it subtracts 1 from NG because we eliminated one of the entries. Then it also subtracts 1 from the active index, so it's no longer pointing at that position. Then it's done deleting, so it didn't put the name delete in the box yet, so it adds a little to X and Y, changes the color to black, the font to 416, and puts the text of delete into the box. Well, let's take a look at what it was doing. It's this box right here. If I click that right now, this entry here in red will be deleted from the list. Alright, this is the end of routine 105 for Polygon scan.